When am I ever going to need this? I'm looking at your screenshot, and I think the answer is never. You are never going to need this. I'm Professor Moon Duchin, mathematician. Today, I'm here to answer any and all math questions on Twitter. This is Math Support. At Records Frisson says, what is an algorithm? Keep hearing this word. The way you spelled algorithm, like it has rhythm in it. I like it. I'm gonna keep it. A mathematician, what we mean by algorithm is just any clear set of rules, a procedure for doing something. The word comes from 9th century Baghdad, where Al-Khwarizmi, his name became algorithm, but he also gave us the word that became algebra. He was just interested in building up the science of manipulating what we would think of as equations. Usually when people say algorithm, they mean something more computery. Right? So usually when we have a computer program, we think of the underlying set of instructions as an algorithm. Given some inputs, it's going to tell you kind of how to make a decision. If an algorithm is just like a precise procedure for doing something, then an example is a procedure that's so precise that a computer can do it. At LlamaLord1091 asks, how the fuck did the Mayans develop the concept of zero? Everybody's got a zero in the sense that everybody's got the concept of nothing. The math concept of zero is kind of the idea that nothing is a number. The heart of it is, how do different cultures incorporate zero as a number? I don't know much about the Mayan example particularly, but you can see different cultures wrestling with, is it a number? What makes it numbery? Math is decided kind of collectively is that it is useful to think about it as a number because you can do arithmetic to it, so it deserves to be called a number. At Just Peacock says, how can math be misused or abused? Because the reputation of math is just being like plain right or wrong and also being really hard, it gives mathematicians a certain kind of authority, and you can definitely see that being abused. And this is true more and more now that data science is kind of taking over the world. But the flip side of that is that math is being used and used well. About 5 years ago, I got obsessed with redistricting and gerrymandering and trying to think about how you could use math models to better and fairer redistricting. Ancient math was being used. If you just close your eyes and do random redistricting, you're not going to get something that's very good for minorities. And now that's become much clearer because of these mathematical models. And when you know that, you can fix it. But I think that's an example of math being used to kind of move the needle in a direction that's pretty good. At Chris X the News. That is hard to say, Analytic Valley Girl. I honestly have no idea what math research looks like, and all I'm envisioning is a dude with a mid-Atlantic accent narrating over footage of guys in lab coats looking at shapes and like a number 4 on a whiteboard. There's this fatal error at the center of your account. The whiteboard. Like, no. Mathematicians are fairly united on this point of disdaining whiteboards together. So we really like these beautiful things called chalkboards. And we especially like this beautiful fetish object, Japanese chalk. And then when you write, it's really smooth. The things that are fun about this, like the colors are really vivid, and also it erases well, which matters. You just feel that much smarter when you're using good chalk. One thing I would say about math research that probably is little known is how collaborative it is. Typical math papers have multiple authors, and we're just working together all the time. It's kind of fun to look back at the paper correspondence of mathematicians from like 100 years ago, who are actually putting all this like cool math into letters and sending them back and forth. We've done this really good job of packaging math to teach it, and so that it looks like it's all done and clean and neat. But math research is like messy and creative and original and new, and you're trying to figure out how things work and how to put them together in new ways. It looks nothing like the math in school, which is sort of a much polished up after the fact, finished product version of something that's actually like out there and messy and weird. So Dylan John Kemp says, serious question that sounds like it's not a serious question for mathematicians, scientists, and engineers. Do people use imaginary numbers to build real things? Yes, they do. You can't do much without them. In particular, equation solving requires these things. They got called imaginary at some point because just people didn't know what to do with them. There were these concepts that you needed to be able to handle and manipulate, but people didn't know whether they count as numbers, no pun intended. Here's the usual number line that you're comfortable with, 0, 1, 2, and so on. Real numbers over here. And then just give me this number up here and call it I. That gives me a building block to get anywhere. So now I come out here, this will be like 3 plus 2i. So I is now the building block that can get me anywhere in space. Yes, every bridge and every spaceship and all the rest. Like, you better hope someone could handle imaginary numbers well. At Litclavini says, hashtag movie errors that bug me. The 7th equation down on the 3rd chalkboard in A Beautiful Mind was erroneously shown with 2 extra variables and an incomplete constant. Boy, that requires some zooming. I will say though, for me and lots of mathematicians, watching the math in movies is a really great sport. So what's going on here is I see a bunch of sums. I see some partial derivatives. This is a movie about John Nash, who is actually famous for a bunch of things in math world. One of them is like game theory ideas in economics, but I do not think that's what's on the board here, if I had to guess. I think what he's doing is earlier, very important work of his. This is like Nash embedding theorems, I think. So this is like fancy geometry. You can't tell because it looks like a bunch of sums and squiggles. You're missing the part of the board that defines the terms. So do I agree with JK Vinny that stuff is missing from the bottom row? I don't think that I do. Sorry, Vinny. At ADHS Jag Club asks, question, without using numbers and without using a search engine, do you know how to explain what pi is in words? You sort of need pi or something like it to talk about any measurements of circles. Everything you want to describe about round things, you need pi to make it precise. Circumference, surface area, volume, anything that relates length to other measurements on circles needs pi. But here's a fun one. So what if you took 4 and you subtracted 4/3 and then you added back 4/5 and then you subtracted 4/7 and so on? So it turns out that if you kept going forever, this actually equals pi. They don't teach you this in school. So this is what's called a power series, and it's pretty much like all the originators of calculus were kind of thinking this way about these like infinite sums. So that's another way to think about pi if you like are allergic to circles. Cause you're the only one. Bro, why did math people have to invent infinity? Because it is so convenient. It completes us. Could we do math without infinity? The fact that the numbers go on forever, 1, 2, 3, 4, ... it would be pretty hard to do math without the ... dots. In other words, without the idea of things that go on forever. We kind of need that. But we maybe didn't have to like create a symbol for it and create an arithmetic around it and create like a geometry for it where there's like a point at infinity. That was optional, but it's pretty. At the Phil Wheelix. What is this sexiest equation? I'm going to show you an identity or a theorem that I love. I just think is really pretty and that I use a lot. So this is about surfaces and the geometry of surfaces. It looks like this. This is called Minsky's product regions theorem. So this is a kind of almost equality that we really like in my kind of math. The picture that goes along with this theorem looks something like this. You have a surface, you have some curves. This is called a genus 2 surface. It's like a double inner tube. It's sort of like 2 hollow donuts kind of sergered together in the middle. And so this is telling you what happens when you take some curves like the ones that I've colored here and you squeeze them really thin. So it's the thin part for a set of curves. And it's telling you that this looks just like what would happen if you like pinched them all the way off and cut open the surface there. You'd get something simpler and a leftover part that is well understood. At Avsa says, what if blockchain is just a plot by math majors to convince governments, VC funds, and billionaires to give money to low-level math research? No. And here's how I know. We're really bad at telling the world what we're doing and incidentally getting money for it. Most people could tell you something about new physics ideas, new chemistry, new biology ideas from, say, the 20th century. And most people probably think there aren't new things in math, right? There are breakthroughs in math all the time. One of the breakthrough ideas from the 20th century is, turns out there aren't 3 basic 3-dimensional geometries. There are 8. Flat, like a piece of paper, round, like a sphere. And then the third one looks like a Pringle. It's this hyperbolic geometry or like saddle shape. Another one is actually, instead of a single Pringle, you pass to a stack of Pringles. So like this. So we call this H2 cross R. Put these all together and you get a 3-dimensional geometry. And then the last 3 are nil, this guy over here, sol, which is a little bit like nil, but it's hard to explain. And then the last one, which I kid you not, is called SL2R twiddle. Really, that's what it's called. Finally, it was proved to like the community's satisfaction, what is now called the geometrization theorem. The idea of how you can build stuff out of those 8 kinds of worlds. It's just one example of the publicity mathematicians are failing to generate. Did we invent blockchain to like get money for ourselves? No, we did not. At Riley Alonza, is geometric group theory just an abelian topology? And then there's this like, my absolute favorite part of this is the laughing, crying emoji, because Riley is just like cracking herself up here. What Riley's, I think, really saying here has to do with just like how much things commute, right? So you're used to AB equals BA. That's when things commute. And then you can sort of do math where that's not true anymore. Where like, you know, AB equals BA times a new thing called C. That's just not the math you learned in school. Like, what is this new thing and how do you understand it? Well, it turns out this is the math of this model here. This is a model of what's called nil or nilpotent geometry. It's pretty cool. As I rotate it, you can probably see that there's some complexity here. From some angles, it looks one way. From some angles, you see different kinds of structure. This is my favorite. I love to think about this one. A and B are kind of moving horizontally, and C is kind of moving up in this model. So that really shows you something about what Riley's calling geometric group theory. You start with just like the group theory of how to multiply things, and it builds geometry for you.
But is it hilarious?
Like, no. It's sort of stringing a bunch of words together and trying to make meaning out of them. And I think that's the joke here. And like all jokes, when you try to explain it, it sounds desperately unfunny. At Ruth Townsend Law. Question for mathematicians. Why do we solve maths problems in a particular order of operations, e.g., why multiplication first? This is like asking in a chess game, how come bishops move diagonally? It's because over time, those rules were developed and they produced a pretty good game. I could make up a chess game where the bishops move differently, but then it would be my burden to show that it's a good game. We could do arithmetic differently, and we do in math all the time. We set up other number systems with other arithmetics. You just have to show that they have some internal consistency, that you can build a good theory around them, and maybe that they're useful for modeling things in the world, and then you're in business. At Hey Arini, how is math supposed to be universal when all our teachers in the same state teach different? The thing about math being universal, there might be like 10 different ways to do long division and get the answer right. We're trying to stabilize math around the world. We're trying to take lots of different mathematical practices and turn them into something where we have enough consensus that we can communicate. At Sham Sandwich says, music is just math that f***s. I'm not quite sure what you mean by that. But there is a lot of math in music. If you think about constructing notes that are going to sound good, to a mathematician, you're just doing rational approximations to logarithms. Transcendental numbers again, like pi. Numbers that can't be made into exact fractions, but can only be approximated in order to decide on the distances between keys on a keyboard. In order to make it sound good, we're trying to approximate something that is a number that can't be exactly captured with fractions. There's a lot to say about the math that's in music. As to the rest of your proposition, I will just trust you on that. At Tuktuku, how does math make sense? Lots of punctuation. Why put a fraction on top of another fraction? When am I ever gonna need this? That is like the thing that math people do, like 6 divided by 2. And that's a very basic thing we like to be able to do. And so the math people come along and say, well, what if I put in different kinds of numbers? What is 6 over minus 2? But that's what mathematicians do. We take a system and we just like try to put in other kinds of inputs that it wasn't expecting. You teach me how to add, and then I come along and I want to add shapes. And you're like, you don't add shapes, you add numbers. And I'm like, but why? We're going to do it every time. We can't be stopped. And when am I ever going to need this? Looking at your screenshot, and I think the answer is never. You are never going to need this. At Neil Vaughn first. A question for mathematicians. Is 0 an odd or even number? Even number is any number that can be written as 2 times k, where k is a whole number. 0 is even if 0 is a whole number. Is 0 a whole number? And you get down a rabbit hole. 0 is even because it's convenient for some things. It is definitely different from the rest of the numbers. You're not wrong about that. At Deftsulal asks, who's the greatest mathematician in history? Does anybody know? And if so, explain why. There are all kinds of incredibly interesting people that are not well enough known. So I'm just going to tell you about a few of my favorites. Felix Hausdorff, he's awesome. He basically built the math behind fractals and did all kinds of other creative stuff, and nobody's ever heard of him outside of math. Emmy Noether, you cannot go wrong with Emmy Noether. She's so interesting. She's a great mathematician, had kind of a cult following. Her math is great. Her ideas are deep. She was a very powerful builder of abstraction, and I think you can't go wrong learning about Emmy Noether. Math is full of these really colorful characters having out of control, original, great ideas. It'd be great if we figured out how to tell their stories a little better. At JHatch17 says, I have a question for math people. If there are an infinite amount of points between any 2 points, but we can still walk from point A to point B, do we walk through infinite points to get there? How do we get anywhere? This is an old and deep question. The idea that math is math, and that it's universal, and that it's all the same, and that it's all figured out, hides a lot of mess, and this is a good example. The theories that let you do that let you describe how points combine to make a line, were actually controversial and took hundreds and hundreds of years to kind of work out to people's satisfaction. The best way to explain how math has built structure to answer this question is calculus. It's about the difference between durations and instants. It's the difference between lines and points. Calculus and what comes after it, measure theory. Those are the ways that mathematicians have built to answer questions like this. At Alejandra Turtle says, I have a question for mathematicians. Why letters in an equation? It's kind of hell. This is one of those great examples where it didn't have to be this way, but some people made some decisions and they caught on and they traveled around the world and people were like, well, it'd be kind of nice if we all did it the same way. And so letters caught on. This is very arbitrary. It's just a convention and we kind of all agreed that we'd do it the same way. Those are all the questions for today. So thank you to Math Twitter and thanks for watching Math Support.